If you were to sit down and try to eat like a chimpanzee, your day would look very different. You would spend upwards of 6 or 7 hours every single day just chewing, grinding through raw, fibrous stalks and bitter fruits that your body is barely equipped to process. Yet, as a human, you likely spend less than an hour a day actually eating, while possessing a brain that is 3 times larger than that of our closest primate relatives. This is the metabolic paradox that defines our species. We have the most expensive organ in the animal kingdom, but we've somehow managed to cut the cost of running it. To understand how we pulled this off, we have to look past the invention of the wheel or the steam engine and focus on a much older technology, the mastery of the flame. We didn't just start cooking food because it tasted better. We started cooking because, without it, the human brain was a biological impossibility. The problem with being a primate is that your brain is a gas guzzler. Even though the human brain makes up only about 2% of our body mass, it consumes a staggering 20% to 25% of our resting metabolic energy. In most mammals, there is a strict mathematical correlation between how big your body is and how much energy you burn at rest, but humans are a massive outlier. We have the energy budget of a standard primate, but we're running a supercomputer in our skulls. In 1995, anthropologists Leslie Aiello and Peter Wheeler proposed a solution to this mystery called the expensive tissue hypothesis. They argued that since our overall metabolic rate stayed the same, we must have paid for our big brains by shrinking another energy-hungry organ. That organ was our gut. The human digestive tract is roughly 60% of the size you'd expect for a primate of our mass. But you can only afford a small, efficient gut if the food you're putting into it is already partially digested. Cooking is, quite literally, a form of externalized digestion. When you apply heat to food, you are performing a chemical pre-processing step that your stomach otherwise would have to do itself. For our ancestors, this thermal shift changed the math of survival. Consider the starch found in wild tubers, the primary fuel source for a growing brain. In its raw state, starch exists in a tightly packed crystalline lattice that is incredibly resistant to human enzymes. But heat triggers a process called gelatinization, uncoiling those glucose chains and making them instantly absorbable in the small intestine. This wasn't just a physical change, it was a genetic one. Modern humans carry multiple copies of the AMY1 gene, which produces the amylase enzyme in our saliva to break down starch, a trait not shared by our primate cousins who eat raw leaves. Cooking turned difficult tubers into high-octane brain fuel, increasing the net energy gain of starches by up to 35% and proteins by as much as 78%. However, there is a massive mystery in the archaeological record that scientists are still trying to solve. About 1.8 million years ago, a new species emerged, Homo erectus. They had smaller teeth, weaker jaws, and narrower rib cages that suggested a significantly smaller gut. They looked like they were eating cooked food, but unambiguous evidence for controlled fire, like hearths and ash, doesn't become common until much later, around 400,000 years ago. Some researchers, like Catherine Zink and Daniel Lieberman, suggest there was a bridge technology, stone tools. They discovered that by simply slicing raw meat with a stone flake or pounding a tuber, early humans could reduce the physical effort of chewing by over 30%. This mechanical processing likely gave our ancestors the initial energetic boost they needed to start growing larger brains, even before they mastered the flame. But once fire entered the scene, the evolution of the human mind went into overdrive. The hearth didn't just change our biology, it completely re-engineered our social lives. Before cooking, survival was a solitary, continuous activity. You spent the daylight hours finding and chewing your own food. But fire created a central place. It forced the tribe to gather in one spot to wait for the meal to be ready. This waiting period created a brand new social opportunity. Anthropologist Polly Wiesner studied the Zhuqiu Huanzi Bushmen and found that daytime talk is almost entirely functional. centered on work, logistics, and social friction. But at night, the conversation shifts. Under the glow of the firelight, humans began to tell stories. This extended awake time allowed for the transmission of culture, the development of complex language, and the ability to coordinate across large social networks. The hearth became the first social media, where we learned to think about things that weren't right in front of us. This new economy of cooked food also likely gave rise to the first sexual division of labor. Primatologist Richard Wrangham proposed the theft hypothesis, suggesting that because cooked food is so concentrated in calories, it became a prime target for bullies or competitors. To protect their investment, women may have recruited male partners as guards, establishing a system of pair bonding where food was traded for protection. Whether it started as a protection racket or a cooperative sharing model, the fire acted as the glue that held the family unit together. Ultimately, we are the cooking ape. Our commitment to a high-quality, cooked diet is so deep that modern raw foodists often struggle to maintain enough body weight or reproductive health on a purely uncooked diet, even with modern grocery stores at their disposal. We have evolved to be biologically dependent on a technology that exists outside of our own bodies. Cooking didn't just give us the calories to grow a large brain, it gave us the time to use it. It freed us from the endless cycle of chewing and allowed us to sit, to listen, and to imagine a world that didn't exist yet. We didn't conquer the planet because we were the strongest or the fastest. We conquered it because we learned how to use a flame to unlock the hidden energy of the world. The next time you're standing over a stove, remember, you're not just making dinner. You're participating in the 2-million-year-old ritual that turned a vulnerable primate into the most dominant mind on the planet. If you want to dive deeper into the ancient instincts that shaped us, check out the rest of the channel. And don't forget to stay curious.